Perpendicular to it, how do I have to see it? I have to see it as a point. I'm going to take this line. I'm going to rotate it 90 degrees. How do I see it? I have to see it as a point. That last line, have to see it as a point. So since I'm seeing it as a point, I'm seeing plane on edge. This is the view that's going to give us our answer. Now, we know that these points all lay on these lines, because that's orthographic projection rule 1. How do I know where they fall? Well, you go back 2 views. I projected from this view. I'm going to go 1, 2. This is my second one back. The distance from fold line to any point on this view will be the same as the distance from the fold line to any point in this view. This is why I said earlier, you have to know the fold line method once we go past a primary rotation auxiliary view. So how do I get this? Well, I know the top is right here on the top. So I'm going to do an offset, and I'm just going to come up here, grab that, and get that distance. So I got the distance, fold line to point, and then I'm going to come down and take this fold line, offset it up.
Up?
Well, back into my view, down. So that was the top line. Now, let's do this again, but this time you're going to use the bottom, because here is the distance fold line to the bottom line is down here. So I'm going to again do offset, make sure you're getting that distance, and offset that out. So again, let me just kind of throw it out there. Call this X. That is X. This is Y. And this dimension here is Y. Okay. So I went fold line to point, fold line to point, fold line to point, fold line to point. Now, what I now know is that I have one line right there, I have one line right there, and I have one line right there. How did that happen? Okay, from here, and that one as a point. From here, you see that one as a point. From here, you see that one as a point. Okay. There's your shape right there, folks. That's it. So once I've got that, I'll just come in here. I know that here is that line, goes to that line, goes to that line. Okay, there it is. You are now looking right down that cut. Kind of put my OBJ lines on there. Does that make sense? A little bit?
A little bit, yeah.
The nice part about this is, I mean, you could grab this thing and just pick angles and try and rotate it, and you'd be all day not getting to that result. But with the laws of descriptive geometry, you're going to nail this thing every time, the first time, and it's going to be correct. Okay, we applied laws 1 and 2 to the dihedral angle, and that allowed us to look down the cut or see the planes on edge. Therefore, we can now measure this and tell somebody the angle of the cut. Kind of cool? Yeah, you bet it is.
That's all we have to find?
That's it. That's all you were doing. Because really, does orthographic projection do the rest of this? Yeah, it does. But this is a 3-view drawing. I'm going to have a front, a right, and a primary depth auxiliary. And I can completely describe the geometry of this object. Okay. Any questions? Should we do the other one?
Yes.
Let's go do the oblique one. There will be a lot of similarities with this to what we just did because we're going to apply the same rules. I'll tell you right now, with obliques, you have to satisfy all three laws of descriptive geometry, all of them. Okay. So first thing, we've got orthographic projection here. I've got a front, top, right. That describes this geometry quite well. I see a plane here that is foreshortened in all views. It's an oblique plane. Now I've got to turn to get true size and shape of this plane. First thing to do is analyze your laws. Where are your true length lines? Where are your true length lines? Remember, there's viewing planes or fold lines in between both of these views. So Majed, in my top view, I've got these labeled 1, 2, or 3. Are there any true length lines in my top view only as it applies to the oblique? So we're just looking at lines 1, 2, 1, 3, and 2, 3. Are any of those in the top view true length? Okay.
1, 2.
What's 1, 3?
Oh, yeah, 1, 3.
Is that parallel to there? Okay. Guess what? That's true length. Andy, how about in the front view? Do I have any true length lines in the front view?
1, 2.
1, 2 is true length. Gabe, how about the right side view? Do I have any true length lines?
2, 3.
Yes, I do. Okay, so I can pick any of those lines to start my rotations on, but that satisfies law 1, because law 1 is all about finding a true length line. So we've already satisfied it, we do not need to apply it. Once we know there's a true length line that's on my plane, I'm then going to go to law 2. Okay, now, since we got more room, I'm going to come off of this guy. So what we're going to do here is we're going to come in, we're going to draw a viewing plane perpendicular to line 2, 3, because that's a true length line. I know, by the way, what am I going to get up here when I rotate this? So I pick line 2, 3, it's true length. I'm going to bring all 3 points. How am I going to see that plane up here? No, I will not see it as a
As a
triangle.
rectangle?
No, we'll see it as a rectangle.
As a diamond.
Law 2. True length line appears as a point
No.
in the viewing plane perpendicular to it. When I see any line that's a point that's associated with a plane, how do I have to see the plane?
Line?
As an edge. Yes, it'll appear as a line or an edge. Okay, so I'm going to get edge view of this plane up here. All right, so let's go ahead and do it. First thing we want to do is make sure we have fold lines between all of our views. So again, if you would, those come in and draw some fold lines. I really only need these 2. At this point, doesn't matter really where they are. Now, one thing that does matter when you set this up, we're not really going to use this view up here, but the distance from this view to this fold line has to be the same as this one. So I'm just going to do an offset of 1 and put both of them right there. Okay. Now, once you're done with that, if you would, draw your fold line off of the right side view. I'm going to make that perpendicular to line 2, 3. be set up something like I've got. Okay. Raise your hand if you need a little more time. Okay, we'll wait. Nope, all it's gotta be is perpendicular to that line. All right, next thing we want to do is we want to project through our picture plane, or our viewing plane. So let's come in, do it perpendicular. I want these to go away, so I'm just going to draw another line out here and extend to it. Okay, that's good. I'll do these on the zero layer. Okay, so I've got my two projection lines. I know line 2, 3 has to be along here, and I know I'm going to see it as a point. I have point 1 is going to be along here, I just don't know where. Okay, how are we going to get that missing dimension? Yeah, so here's the way I think of this. Here's my current view that I'm building. I project from 1 back. Okay, that's what we did. And then you're going to do fold line to point, fold to point on 2 back. And by the 2 back, I mean the drawing. So I'm current, I project from 1 back, and then I go fold line to point on 2 back, because I need 2 views to build any one. So the thing I need to now do is go fold line to point will be the same as fold line to point. Now notice point 2 and 3 are parallel, so I only got to do one of those. So I'm going to do an offset command again, and I'll just come from there, that's that point. Then I do it again, all the way to point 1, that's this point. What I'm going to end up with here is a line that looks like this. Where here is point 3, 2, there's point 1.
So you're using which fold line points were you
Okay,
using?
I projected from this one, so I had to go fold line to point. So this distance right here is that distance. So I went fold line to point, fold line to point. That gives me 0.23. Because that distance is the distance from fold line to 3, fold line to 2.
Why did you choose to work from the back forward instead of beyond?
Doesn't matter which way you work.
Doesn't matter.
No, you're projecting points. You're projecting points. I could have done 1 first, or I could have done 2 or 3 first. It doesn't matter. Yes, Beth?
So I did, for my fold lines, I did mid between 2 points, so mid between the 2 projections. So I can work off my last.
No, it doesn't matter where this sits. Okay, you got it right here directly in between, right?
Yeah.
Doesn't matter. It's gonna be good, don't move it. Once you get it set, it doesn't really matter where it sits, okay? Now, I made sure that these two were the same, but I'm not gonna use this view, so this isn't pertinent for this.
Uh-huh.
You don't even need it. You put it right here in the middle, all it's gonna do is kind of move this up or down. Okay, but it's irrelevant, it's still gonna be correct.
Okay.
Okay, we don't really care about this distance in here. Once we set it, I mean, it's locked in. All right, does everybody get these two views? Or the new view?
Yep.
So you should have this,
Just that?
just that.
That's true.
Okay, so we've applied law one, we did right on the object, right? So there was law one. That gave us true length, correct? We just applied law two, which is my edge view law. Okay. Now we need to apply law three. What does law three state? Okay, so what are we gonna do? We're gonna come in here and we're gonna draw a viewing plane parallel to this one and project into this view, and I should have this plane true size and shape. So that's in essence what we now need to do.
And will we like offset it to a certain distance?
Yep, and we just keep moving 2 views back. Okay? So here's the process. First thing, I'm just gonna come in here and I'll draw a line. This time I gotta use parallel snap. I haven't used that one in a while. Okay. So there's my viewing plane. And again, I just picked it. I didn't care where it was. All I care is that it's parallel to my edge view. Then I'm gonna project perpendicular to that. And again, I want these to go by a little bit, so I'll just extend them one out.